Today we are going to talk a little bit more specifically about those simple machines that make work easier. And so we did a quick recap prior about the 6 simple machines, and we're going to dive into those in just a little bit. So we have the incline plane, screw, wedge, lever, pulley, and wheel and axle. And what's cool is that you can actually trace this throughout human history. Some of you might have seen like images or cartoons about the invention of the wheel and how that was such a big deal. But the history behind these is relatively unique. So one of the things that we see with the inclined plane is we see this with the Egyptians and civilizations that really looked at how these inclined planes can help out and to create something of large magnitude. And when we see these, we really start to see how those things really made possible the structure and the creation of some of these large civilizations. So the inclined plane, they used a method to build the pyramids. And basically, they started off with wide bases, and then they worked their way up to the top. Sometimes when you get little toddlers that try to make something really tall, they don't build the foundation. So instead, they build something and oftentimes collapses. But when we talk about how those inclined planes with a larger base and then easing that work, it makes things a lot easier. So the Egyptians are one of the first ones that really practice and use the inclined plane. Now, how do we use it today? So an inclined plane allows us to use gravity to help us out. So if you've ever noticed that your bathtub is actually slightly slanted towards the drain, that's because we use the flow of gravity and the flow of water. Water goes from the path of least resistance because of gravity to flow down. And so it makes things easier, and it also will spread out that work over longer distances. So a sloping surface, which is like an inclined plane and a ramp, it allows us to spread out that work a little bit easier. You need less energy and force to move objects with an inclined plane. All right. We can also see that with a formula that is used with what we call work input versus work output. And this is an equation that I want you guys to memorize or anything. But basically what it's saying is, let's just look at the first bullet here. The work input is the amount of work done on a machine. All right. And so that can be changed based on the distance that is used. Work output is the amount of work done by a machine, so output force times output distance. Now, what does all of this mean? Basically, what it means is the longer the ramp is, the more work is spread out. So you're still doing the work, it's just done with less power, going back to the word that we introduced from our previous video. So that mechanical advantage is helpful because you're spreading out that work. And so if you have a ramp with, various angles, you really can increase or decrease the amount of work that is done. And so that's the reason why stairs typically are a certain size. We don't have really, really shallow stairs unless it's something for architectural purposes. And so that's why the inclined plane is used in houses with multiple stories. Let's next talk about our next simple machine, which isn't necessarily a machine, but more of a tool that's used. And so what we do here is with those threads is that we're increasing the surface area of the attachment of whatever it is that we are attaching. And so screws are super beneficial because they have a tighter hold than a nail. If you think about it, if any of you have ever taken a hammer and you've pulled out a nail, it comes out fairly easy, depending on the size, of course. But if you take let's say a hammer again, and you try to pull out a screw, it is a pain in the rear to try to do so. Why? Well, the screws are designed to have those threads and to really increase the surface area to the attachment of that board or whatever it is that you're merging together. We see the same with like nuts and bolts and the attachment that they give. All right, you're basically making it harder to take something out and to decrease the attachment when you have those threads on the screw. Our next one is the wedge. So the example that I want to give here is, let's say that I tried to make you guys cut a piece of wood with a hammer. Could it work? Yeah, but it's going to take a heck of a lot more hammers to make the wood split. What a wedge does, the shape of it is what's important, is that it makes it so that you start off with breaking something small and then spread out as you go. And so wedges are designed to split things, and the shape is very, very important. We know that the same thing is true with a knife. So again, if I told you, hey, cut this watermelon with this spatula, it's not going to work out so good. But if you take it with a knife, now we're talking. All right, and so that's what wedges are for. And so again, if we think about this in formula, and again, this is not something that you have to write down, but what we're trying to do is we are trying to decrease the surface that we're dealing with. So by having something that's pointed, by having something that's a wedge, we are doing work in a smaller area. All right, and that's known as the actual mechanical advantage. But then we also have the ideal mechanical advantage, where we're really trying to, again, just take a look at one area, really spread out our work over a smaller area, and then have it spread out once that work has been done. All right. Our next machine that we're going to talk about is the lever. And so there's actually three classes of levers. And so we got to talk about a few vocab things here. So E is for effort, R is for resistance, and then the fulcrum is basically like where the thing pivots. And so depending on where I put this fulcrum, there needs to be more or less effort in order to move the load. So for example, if I put the fulcrum, over here, I would require more effort to push something. And so this and where this fulcrum is can really change where or how much work is happening. So let's look at some actual examples here because it's just easier to think about it like this. We see this with things like crowbars. We see this with scissors. We see it with seesaws. And that's a first class lever. It allows us to perhaps, and we see this sometimes with like catapults in some ancient cultures and how they launch various things in warfare. And so that's what we call a first class lever. The second class lever is now taking both the resistance and the effort needed to move it, and the fulcrum is on like one of the edges. So effort moves further than the resistance. And again, let's just kind of think of some examples because it's easier to think of this. And then if you want to revisit the slide, you certainly can. But some examples of this would be like nutcrackers, wheelbarrows, doors, bottle openers. And so if we go back to the image, all right, let's say that this is the bottle cap. This is the tool that's used, the resistance, and then the effort that's needed to pop off the bottle. That's how a second class lever works. If we're talking about a wheelbarrow, this is the wheel. The resistance is the load that we're carrying. Let's say we're carrying a wheelbarrow of soil, and then the effort is to lift the wheelbarrow, but then move it in that direction. So that's a second class lever. The third class lever is something that we look at with this image. So again, the fulcrum is on the edges, and what we're seeing here is that the resistance moves further than the effort. And so this is another example. We could analyze the mechanical advantage, but that's something that we don't necessarily need to know for our purposes. But our examples would be like a tweezers, would be an arm hammer, all right, or for us like a curl. Shovels would be an example of this. And so this is one of our simple machines. We call these levers. Our next type of simple machine is what we call a pulley. So a pulley are wheels that are used as well as axles, and they also require a rope. And this allows us to move larger masses with less force. So instead of carrying up a 50-pound brick straight up and lift it on a ladder, we can use a pulley, and it takes much, much less work in order to do so. So some examples of our pulleys would be a fixed pulley, which is like, let's take that brick example. Here's our 50-pound brick. We're pulling down on that to make it rise. A movable pulley would be more so the movement of an object. So sometimes we see these in like manufacturing plants, or we might see these in meat processing plants, that sort of thing. And sometimes we can actually combine pulleys, and that spreads out the work that much more. But of course, there, the only disadvantage is you need, or you're traveling longer distance, and you have to apply the force for a longer period of time. And so the last one that we're going to talk about today is we're going to talk about the wheel and axle. And this one was really, really big with modern civilization and also ancient civilizations because it really allows us to move larger objects. And so an axle, hopefully we understand what that is what the wheel spins on or upon. So without the axle, wheels don't serve much of a purpose. Without the wheel, axles don't really do much either. But the combination of them really, really helped out with the movement of things. And so if you think about the carts that we've been using in Science 9, or if you think about the car that you drive on, or the bike, yeah, the wheels are moving, but also that axle is what it spins upon. And so the wheels are what's really doing a lot of the movement. They are moving more, where the axle is just causing a place for it to spin. And so those are just kind of some examples of some of our simple machines. But then also we can kind of combine this wheel and axle and some of our other things like pulleys and levers and those sort of things with gears. And those of you that know engines very well, there is a lot of work. So that definition of work that is done with those wheels and axles. So for a vehicle to move, we are using the engine, the pistons, to move those things, which move axles, which move gears, which then move our wheels. They're going in similar directions. And so our vehicles, carts, four-wheelers, dirt bikes, all that stuff certainly require all these things that we're talking about. And they're able to do this work, and they're able to do these things because of these simple machines that are all combining together. And so one of the things that we'll really look at is, so a vehicle, let's say a car, has a whole bunch of things going on. There's no doubt about that. And there's a guy by the name of Rube Goldberg. And what he did is he took that idea of like a vehicle and took simple machines and got it to do some things and really made complex things. Now, he did, like, let's say you start off by kicking a can and then it eventually turns on your light. So he wasn't doing things like creating vehicles, but he really set the precedence for how using simple machines can really allow you to do a lot of work. Yeah, it takes multiple steps, but still you're doing a lot of work. And so here's kind of just an example of a Rube Goldberg. And so what it's saying is you have, the levers here in the clock. The alarm clock gives off energy because it's buzzing. It hits this marble. Now you're doing a wheel and axle where this marble eventually is going to drop. It's going to cause this cup to flip over. So there you're showing kind of some lever. That adds weight to this bucket. So now you're causing the string to pull down on the scissor, another lever. That cuts the string, which now is going to let the shoe fall, kick the stapler, which is another lever, and boom, you've stapled the paper. So obviously that's a whole bunch of steps, but what he really did is he said you can take these simple machines, have them work together, and really do some cool things. And obviously we know that very, very well with some of the different vehicles that we have. And so in closing, we can take all of these simple machines that we've talked about and really get a lot of work done. And that's what's kind of cool and really a emphasis in this chapter, and has really helped human history, human civilization throughout. So just think about some of the vehicles, some of the different things that you have around your house right now, and what they are using to do work.